Hi, welcome back. We're going to continue talking about evaluating expressions as we continue this unit. Uh, Today's lesson will be focused on simplifying square roots, another operation that we can use when we are simplifying expressions in algebra. So let's continue on with uh, what is the definition of a square root? So let's take, for instance, we learned last time that 3 squared, when we take that power, write that a little bit neater. When we take 3 and square it, that means we're taking 3, multiplying it by itself 2 times. So 3 squared is equal to 9. When we talk about a square root, that would be the inverse operation of taking a square of something, or raising something to the second power. So 3 is a square root of 9, because that's the inverse of squaring 3. So b squared equals a, b is the square root of a. So we're just looking for the number that when you square it, it gives you that value. So all positive real numbers have 2 square roots. The positive square root, which is the principal square root, but there's also a negative square root. So say, for instance, 3 is the square root of 9, but negative 3 could also be the square root of 9, because negative 3 times negative 3 is also 9. So keep that in mind. Typically, we're only talking about the positive one, but as we get further into class and as we get deeper into algebra, we'll be looking at the negative square root as well. Just so we're clear, also this symbol here is the radical sign. Tells us that we need to take the square root of a here. And a is the radicand, is the terminology we use. So negative square root of 9. So order of operations, we treat this radical as like a parentheses. So square root of 9 is 3, and then we multiply by a negative 1. So negative 3. We would simplify that as square root of 25. I think what number times itself gives us 25, and that would be 5. Number 3, we have this plus or minus symbol here. That's just dealing with those 2 square roots that every number has. So we take the square root of 64, which is 8, and it could be either a positive or a negative 8. And for our purposes here, if it shows a plus or minus, we'll put that in our solution as well. And here we have the negative square root of 81. So we take the square root of 81, which is 9, and then we're going to multiply by a negative 1 to get negative 9. And that's how we evaluate what we term the perfect squares. The perfect squares, as I mentioned, those are the square roots. When we take the square root of the number, we get a whole number. Okay, and we can use those perfect squares to help us approximate different values. So it's important to have those perfect squares listed and learned. Makes it our job easier once we start working with square roots. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9. Hopefully you're seeing the pattern here. 10, 11, 12, 13, 14, and we got one more down here, 15. So if you can kind of commit these to memory, these are many of the square roots that you'll be using quite often. Pause it if you need to write those down. Now, how do we use this? So if we have, if we want to take the square root of 32, okay, if we're taking the square root of 32, it's not going to come out as a whole number. But we can take a look at, well, square root of 32 is between square root of 25 and square root of 36. So it's going to be between 5 and 6. 32 is closer to 36. So we'll say that square root of 32 is about 6. And that's what that those squiggly lines mean. That's the way we write approximately or about. Square root of 103. Go down our chart. It's between 100 and 121. It's closer to square root of 100. So that's going to be approximately 10 to the nearest whole number. Then the negative square root of 48. We'll deal with the negative later, but square root of 48 is in between these two. Closer to the square root of 49, so it's approximately, now we can take a look at the negative. We make it negative now, -7. And negative square root of 350. Well, here's where you might need to do a little bit of estimation. Since we only have our chart up to 15, well, we can take some of these other numbers like 20. 20 times 20 is 400. So it's less than that, so let's try the number below that, 19. Well, 19 times 19 is, well, you can check that on your calculator. 10 times 10 is 100. 9 times 10 is 90, plus another 90. 280. Hopefully I'm correct so far. Plus 9 times 9 is 81. So 361. Oops. Write that down. So 361. And that's going to give us our value that's very close. We'll say it's approximately negative. Oops, not letting me write anymore. So negative 19. And that's how we can use our knowledge of perfect squares to help us approximate. Okay, next let's talk about the numbering system. So the numbers that we're going to talk about here are the real numbers. You'll get into imaginary numbers as you get further into your math career, into Algebra 2. We're just talking about the real numbers, the ones that we work with and use. They're in two broad categories, either rational or irrational numbers. The rational ones, you can see the word ratio in there. Ones that can be written as a ratio. So 3/4 or 0.75 as a decimal. 1/3, 0.3 repeating. You know, this decimal goes on forever. It has a set pattern. Anytime we have a decimal that repeats, we can write that as a ratio. These integers, -4 and -1, those can also be written as a ratio. Remember, if I take -4 and divide it by 1, I still get -4. So all these numbers on the left side are rational numbers. The irrational ones are ones that cannot be written as a ratio. For example, square root of 2. It's between 1 and 2 because the square root of 1 is 1. Square root of 4 is 2. But we can't quite get an integer with that. The number pi is also an irrational number. It's about 3.14. So irrational numbers are their own category. Within rational, we can break those down into integers. Those are numbers without any decimal or fractions after them. It's just the -4 or the -1 or a 5 could be an integer. Integers are both positive and negative. And then once we classify the whole numbers, those are just positive. Those also include 0. So the whole numbers are the ones we get when we take the values of those perfect squares. Okay? So just to review those numbers, let's just take a look at the following numbers and how we can classify them. So square root of 144, the numbers that we're talking about are all real numbers. Is it rational? Well, what's the square root of 144? It's 12. Write it as a ratio, 12/1. If it's rational, it means it can't be irrational. Is this also an integer? Well, it doesn't have a decimal or fraction attached to the end of it. It's just 12. So we would say that's an integer, and since it's positive, it would be a whole number. Okay, next number, negative square root of 49. Real number, yes. Is it rational? Can I write it as a ratio? Well, square root of 49 is 7. Make it negative 7. I can write negative 7 as a ratio, negative 7 over 1. Which means it's not irrational. Is negative 7 also an integer? Yes. But it is not a whole number. Why is it not a whole number? Because it's negative. Square root of 32. Is it a real number? Yes. Rational. Well, if you remember, it's not one of those perfect squares. So if we take the square root, it's going to give us a decimal that repeats without a set pattern, which will mean this is going to be an irrational number. And if it's irrational, it can't be an integer or a whole number.